Hello and welcome back. Let's do one more example, and then I'll go through something that I find fairly interesting. So here we've got again, we want to take a second derivative, and here we have e to the x over x. So in order to do this, I'm going to use the quotient rule, and because I'm taking a second derivative, I'm just going to do the first derivative first, and then move on to the second derivative. So let's just take the first derivative of our function e to the x over x. This is again going to be another fraction. On the bottom of the fraction, I will have an x squared. I'll take the bottom squared. And for the top of the fraction, I take the bottom times the derivative of the top minus the top times the derivative of the bottom. And this is fairly straightforward to simplify. The derivative of e to the x is e to the x. This is one of our nice functions. We're going to subtract e to the x times the derivative of x. Well, the derivative of x is just 1. And that. So ultimately, if I pull out an e to the x, I've got x minus 1 times e to the x all over x squared. So again, this is fairly straightforward when we have things that are the derivative of e to the x and the derivative of x. This could be a lot more complicated if I chose different things for the top and bottom, but so far this is fairly straightforward. Let's take the second derivative now, which is what the question originally asked for. I want to take the derivative of this guy, so we get x minus 1 times e to the x all over x squared. So again, let's make this a bigger function. On the bottom, we'll have x squared squared, and then we'll take the bottom times the derivative of the top. This is going to be x minus 1 times e to the x. We're going to subtract the top times the derivative of the bottom. And this is where things will get a little bit messy, but nothing that we can't handle. So let's just have the bottom of the fraction. So x squared squared is going to be x to the 4th power, x to the 2 times 2 power. I've got my x squared here, and now I want the derivative of this guy. So I have two things being multiplied together, right? I've got x minus 1 times e to the x. So let's take a derivative. I'll take the derivative of the first guy. And then I'm going to take that times e to the x, and we're going to add the first guy times the derivative of e to the x. So again, I just take the derivative of the first guy, derivative of the second guy, and we're going to multiply them by the other functions. And then over here, we've got x minus 1 times e to the x times the derivative of x squared. Well, that's just going to be 2x. So let's keep simplifying. I hope I don't run out of room here. Maybe I'll scoot this up one. So we've got our function. We still have x to the 4th on the bottom. We've got an x squared. The derivative of x minus 1. Derivative of x is 1. Derivative of 1 is 0. And 1 minus 0 is just 1, which makes this whole derivative 1. And 1 times e to the x is e to the x. So this guy just becomes 1, this derivative. And then we're going to add x minus 1 times the derivative of e to the x, which is just e to the x. And then we'll subtract this guy. So I'm going to distribute the x squared. So that will be 2x squared minus 2x times e to the x. And I'm going to start factoring some things out. So I have an x to the 4th, and maybe up here, I'll quickly note, I'll distribute the x squared, but I'll also pull out an e to the x. So I'll just write the e to the x out front, and let's see everything that happens here. So I have an x squared times e to the x, and then I've got an x squared times x minus 1. So the x squared times the x, and then the x squared times the minus 1. And then we're going to subtract the 2x squared, and subtracting a negative is going to be plus 2x. So again, I have the x squared. This is x squared times x minus 1. And then I have the minus x squared and a minus 2x. And I think we can simplify this quite a bit. X squared and minus x squared cancel out. And I can cancel at least one copy of x from each of those. So our final answer is going to be e to the x times, we've got an x squared minus 2x plus 2 all over x to the third power, which I don't necessarily see any logical intuition why this would be the second derivative of e to the x over x, but I feel like each step was fairly reasonable. We just had some simplification to do in places, and some rather easy sort of derivatives on the inside. And what I'll do is I'll finish up with a little bit of food for thought. So the following is how exponentials and logarithms work. We know that if we take the log base b of b to the x power, what we're doing is we're asking b to what power is b to the x? Well, that's just x. So in particular, if I take log base b of b, I get 1. And ultimately, if I take the natural log of see here, where was I going with this? So if I take the natural log of, oops, I don't need the base in here. If I take the natural log of e, I get 1. And this also works in reverse. So this is just a little bit of review. If I take e to the natural log of x, I also get x. As in, if I take b to the log base b of x, I get x. So this right here and this right here are just how logarithms work, and I in particular want to focus on this guy right here. So what I could do is I could say the following. Let's say 2 is going to be equal to e to the natural log of 2. So if we look at this equation here, I can write 2 as e to a power. Okay, so far, so good. I can raise both sides to the x power. Okay, and what happens when I take an exponent raised to an exponent? This is going to be e to the natural log of 2 times x. And here, this is where I can say the following. I told you that the derivative of 2 to the x is going to be 2 to the x times the natural log of 2. it's always the same thing times the natural log of the base. So let's look at this guy and see what its derivative is. The derivative of e to the natural log of 2 times x. Well, the derivative here, I'm just going to have to use the chain rule. So the derivative of e to any power is just itself. But I need to take it times the derivative of what's on the inside. So what is the derivative of a constant times x? Well, that constant just comes out, and the derivative of x is just 1. And lastly, e to the natural log of 2 is just equal to 2. So e to the natural log of 2 times x is just 2 to the x. So out of these two formulas, which one is easier to remember? Is it easier to turn 2 to the x into e to the something and then take the derivative? Or is it just easier to leave 2 to the x as 2 to the x and take the derivative? This way is much easier, but it's always important to keep in the back of your mind that no matter what exponent you're ever doing, if you have if you have b to the x, and for some reason or another, maybe b to the x is a little bit hard to deal with, you can always turn b to the x into e to the natural log of b times x. And now we have an exponential with base e. And base e exponentials are often a lot easier to deal with. So ultimately, if you're stuck and we can't simplify something with base b, we can always turn it into base e, and it may be easier to simplify. This is not strictly necessary for the homework that we're doing right now, but it's just something to keep in the back of your mind. All exponentials are exponentials base e after a little bit of work.